So welcome everyone physically present or on Zoom or through YouTube to Flower Summit 2022. My name is Nicholas Lane. I'm an associate professor at the University of Cambridge. I'm also head of the Samsung AI Lab in Cambridge. But today, it's my pleasure to moderate today's proceedings as one of the, low number of thousands of people who contribute to Flower currently, whether it be through code, whether it be through using the framework to produce their research, whether it be from organizations experimenting with federated learning in various kinds. And so I thought I'd begin with just a little bit of a personal story about why I'm so passionate about federated learning. And as you'll go through the day, you'll hear from many other folks who have different perspectives on federated learning and why it's so important. But for me, I think it's our chance to completely change the way machine learning works. We are trapped today in a situation that is centralized. It's premised on data centers, and there's a huge number of negative externalities that extend from this sort of prison that we are in that prevent us from inventing applications and doing many things that really are just desperately required by society. Today, this is what the world looks like. We're talking about large number of GPUs. Typically, the scale of this means that corporate interests rule. These are huge models, and so therefore they need to be trained by these giant static data sets that are stuck in these data centers, and you can't escape this. Whether every time you do a search on Google, every time you use your phone, there's 80 or hundreds of models being used, most of them cloud-based. Every time you use Alexa, every time you sit on your couch and watch Netflix, there are hundreds of models being used, and they're all trained, served from the data center. And that needs to change. I'm pretty certain that in about 10 years' time, we're going to look back at this paradigm and think to ourselves, there's a lot of strong parallels between this and something like that. And this, of course, is smoking. Used to be fine to do in the 50s. Doctors used to say, go for your life, smoke as much as you want. There's also practices that we've got pivoted away from, such as this. This is lead paint. It used to be completely fine to paint your house with lead paint and stick a kid in the room and have God knows what inhaled by the kid. Because why? Because we wanted the room to be a certain color, and there was no technological different way of doing it at the right type of cost, at the right type of facility. There basically was no other option to us available. There's, of course, a lot of other types of societal ills that we want to steer clear from that we haven't quite managed to migrate from, because technology does not quite exist yet to help us solve things like climate change or the way we hit our environment. But my point in this sort of like roundabout way of talking about societal ills and how we've moved and migrated away from them is that I think that the data center combined with machine learning is going to go down in history as being one of these examples. And so why is that? People often say we need decentralized machine learning and federated learning for the reasons of privacy. And certainly that is a key aspect, but it's only one of a long tail of reasons why we need to move away from the data center. So user privacy and access to control is one pillar, but not the only one. Safety and brittle systems, the safetiness of our AI is going to be more brittle if the intelligence of these systems rely on data centers. If you're going to invent some next generation stethoscope to listen to a heart and the model happens to exist in a data center, well, God help you if the network actually starts to fail, right? There's a lot of discussion about fairness in models and its ability to generalize across different demographics and different geographic constraints. The fact is that the data center paradigm, which ties to it static, heavily curated data, that does not change because it's complex to collect, it's very expensive. And so those types of systems are trapped in using static data that is never going to generalize across the world. It's no shock if you're not going to be able to fit and find someone's face across all the different demographic variations because there's no chance of being able to build data sets of that kind. So again, that's another reason why data centers are a poor fit. Of course, carbon's a terrible issue. We all know it's no surprise if you're going to use a lot of GPUs, thousands of GPUs, naturally you're going to use a lot of energy, and that's going to have a huge carbon footprint. So these are all the problems that data centers have with them. And we think in the world of federated learning is one vehicle forward for transforming the way machine learning can be conducted that can address all of these ills. One of the interesting elements of this is that in its present evolution of federated learning, you only see toy examples being done, right? So then if you look at the top middle aspect, is that this sort of interesting inflection point in development where federated learning is in some aspects everywhere and in other aspects nowhere. Because in the middle here, we have keyboards. Every time I grab my Android keyboard, it's federated trained, right? But then if I want to use machine learning to solve if I want to use federated learning to solve a machine learning problem that's a bit more of a bigger importance. So something like being able to share data between hospitals to train sort of recognition of cancer. All of the other types of applications of machine learning cannot be applied today through federated methods. And the reasons for that, I believe, is that we're at a point in the evolution of our tools that is very early. I remember back in 2012, if you want to even look at the confusion matrix of a deep learning model, you'd have to use something like Torch and write dozens and dozens of lines of code to get that confusion matrix out. And yet today, there's so many different frameworks. It's a trivial thing that undergraduates are doing, fantastic training of large-scale neural networks. So my point being that federated learning is at a similar point. It's far too hard to do, to apply it, to innovate, to explore it properly. And that's the role we think Flower can play. So this has been a very long-winded but personal view on why I'm so passionate about Flower, and I want to put all my energy behind it. I want to explain then what's the rest of the day going to look like. Well, this year, we've got a threefold increase in the number of people participating. So right now, the registrations are about 550 odd people. They're joined via YouTube and online. And we're going to review in the summit today, I think, three main types of discussion. So there's going to be discussion from people like Micah at Intel or Peter at Google at ML Commons, who are going to be talking about these partnerships that are emerging between Flower and important organizations to do with, for example, profiling how the future of federated learning needs to sort of move forward in terms of measurement analysis. And in terms of Intel, Micah is going to be talking about how some of the ideas of OpenFL are starting to blend with that of Flower and where it might end up in the future. You're also going to be hearing about where Flower is going. So Daniel very momentarily is going to tell you about the future direction of Flower, and later Maria and Pedro are also going to tell you about some of the core building blocks that are evolving that can be used by both researchers and industry folks. And then I've cherry-picked a few of the folks at the bottom here, and they're going to explain to us how they've been using Flower for innovating inside their company in the case of Flower, or innovating inside the university in the case of people like Shinchi. We're also really happy to have folks from Brave who are going to be talking about an important partnership emerging from Flower that's looking at how you can prototype privacy-preserving ads with those two sort of things meeting. So we've got 4 sessions. This first session is going to be a discussion from Daniel about the evolution of the platform. We're going to have Peter talking about, from an ML Commons point of view, how Flower and data learning might evolve. And then we're going to finish off with an important application domain that is being serviced very heavily from the framework in the dimension of health. And so before I hand over to Daniel, I just want to briefly make our first announcement of the day. And the first announcement is that we naturally think that federated learning is something that everyone needs to know how to jump onto, understand the inner workings of, and then use it within their daily life. So how best should a professor do this? They're going to make a class. And so starting next year in January 23 at Lent term, there's a brand new class that's going to be in Cambridge. It's going to be called Federated Learning Theory and Practice, and it's going to be built from the ground up using Flower. So then you can learn about all the principles and then start to apply those principles in practice. It's going to be available to all Cambridge students from part 2 upwards, but also a version will be available worldwide. So that's our first very tiny announcement, but Daniel is going to give us dozens of more. So I'll hand over to Daniel. I've known Daniel now for more than 2 years, maybe 2.5 years. And when he first showed me a very early working version of Flower as part of his master's thesis. And I couldn't believe what I saw. And so from that point onwards, we started to work heavily together to see how we can bring it to its sort of full fruition. So with that, I'm very happy to hand over to Daniel.
Thank you very much for that introduction. So I'm super excited to be here to give an introduction, give an update on where we are with the Flower platform. I'm going to announce a couple of things that we've really been working towards for more than 2 years now. Flower has grown massively over the last 2 years, but not only has it grown, it's also made its way into very different industries. But before we go into these details, let's look at the problem that Flower is actually trying to solve and actually trying to address. What we want to achieve with Flower is to provide an infrastructure, a unified infrastructure that is accessible and that allows us to build federated applications, whether that's federated learning or federated analytics or federated evaluation or some other spin on it. And it shouldn't really matter whether we are tackling a cross-silo case. For example, if we want to train a model across the data sets of multiple hospitals. And it shouldn't matter whether we want to tackle a cross-device case, whether we want to train a model across multiple phones, or maybe it's not phones, maybe it's a slightly bigger device like a car. So what we really want is some kind of agnostic infrastructure, modular and agnostic infrastructure that allows us to just reuse certain components that we have, apply them in a cross-silo case, apply them in a cross-device case. And usually we want to have some hybrid version of federated learning mixed with federated analytics, maybe also federated evaluation. And we want to run this across very different kinds of devices and organizations. And then on the server side, we want to plug in these different kind of strategies and different kind of approaches, want to combine them in a very flexible way, and also want to integrate it with other kinds of third-party systems. For example, we want to track our experiments with TensorBoard or weights and biases, or integrated with some other kind of third-party system. And to make things more complicated, we not only want to do this in a real-world setup, but usually when we start to develop these systems and start to think about ideas, we want to start on a single machine. We usually want to start maybe on our development laptop, quickly prototype something. And then once we're happy with what we have, we want to move this to a compute cluster and scale up the simulation. We want to run it with more clients, or we want to move it to a device cluster to see how it behaves in the real world running on real devices. And then once we're happy with the simulations and everything goes well, we might want to evolve it towards a production system and then deploy it really at scale in a reliable manner across a globally distributed fleet of devices. So Flower already offers a lot of capabilities that allow you to do this. It allows you to combine Flower with different machine learning frameworks like PyTorch, TensorFlow, JAX. It has the virtual client engine, which allows you to scale up simulations massively. There's an edge client engine that allows you to run this on real devices. You can use it with different programming languages. You can mix virtual and real clients. You can run on Colab, which is great for teaching. You can combine it with other frameworks, for example, SpeechBrain. You can capture real-world metrics to measure the energy consumption and see what the carbon impact is, for example. And then finally, if you want to deploy it in the real world, you can deploy it in different cloud or on-prem environments. So what happened since Flower Summit 2021? Well, first we crossed this magic number of 1,000 stars on GitHub, which is a big milestone for any project, but it's particularly exciting given that we're not some kind of web front-end library where there's a huge audience, but we're still in a little bit of a niche topic that people are still learning about. So it's even better. And just to make sure that we capture everything, if you're a fan of Flower and you haven't given it a star yet, please do so immediately. What's even more exciting than the number itself is that our community is really globally distributed, and this is a great thing, because one of the goals that Flower has is really to make federated approaches more accessible. And just plotting this out on a map shows that we are really going this direction, and that we make it accessible also to people who are maybe living outside of the usual tech hubs. We have 42 contributors so far. 23 of them were added over the last year. We have 339,000 downloads distributed across Flower and Flower Nightly. One thing we found pretty surprising was that Flower Nightly is very popular. So users like to live on a cutting edge version. And we have more than 3x the registrations for Flower Summit this year compared to last year. But these are large numbers, and one of the one single data point that I want to share is this email that I recently received. I blacked out some of the parts of it, but I really wanted to read it to you, because this is something that we get these every once in a while, and it really makes our day, and it's nice to share it with all the contributors. So this is just a rapid message to thank you for the great framework, and to inform you that we use it in our research group since around 2 years ago. Yeah, this is, if you're using Flower and you like it, I can only encourage you to share such a message with the contributors and with the maintainers. They really appreciate it. We've added a ton of features over the last year. I will not go into them in detail. Check the release notes for details. And we are also, with one area that gained a lot of attention over the last year is federated learning in healthcare. And this is something that we care deeply about. Advances in healthcare will eventually benefit all of us, our families and friends. So it's a very important domain to work on. And we are very fortunate, I should say, that we can contribute to support direction, either by helping companies and other organizations use Flower, or by just participating in discussions on where federated technologies need to go and where frameworks need to go to make it easier to apply it in the healthcare domain. One thing we started over the last year, and there's a big shout out to our friends over Jan and Orlando over at Cthulhu, is the Flower enhancement doc process called FEDS, where we start to open up the design process for new features. So the FEDS 0001 describes this process. And we are now starting to make, if we're working on new initiatives, and if we're working on new features that have a bigger impact, we're starting to write these Flower enhancement docs to make sure that we get everyone on the same page, that we agree on a design, that we consider all of the aspects that are necessary before we really go ahead and start to implement this change. And this is also an opportunity for the community to really contribute to this. So if you have an idea on how to advance Flower and what you would like to see, then please go ahead and open a pull request that describes how this feature should work. And then everyone can jump in and contribute their thoughts. And yeah, we can evolve this doc together before we go ahead and implement it. With that, it's time for more announcements. Flower 0.20 is not going to happen. So the big announcement is the next version of Flower is going to be 1.0. 1.0 is stable. Maybe some of you have already seen it in the commit history. We have changed not only the version, but there's a second line that has changed as well. And I think that's the more important part. It's not just a different version, but it's really a promise for stability going forward. Over the last, well, more than 2 years between Flower 0.1 and 0.19, we've iterated quite a lot on the APIs to make them more usable, make them more generalizable, make them more flexible. but still keep them easy to use. This is not always an easy thing to achieve in an API design. But now we feel confident that we have something that we can actually where we can actually promise stability going forward. So there are also a couple of improvements in 1.0. We will make all client methods optional, just because some of them don't always make sense. If you use centralized evaluation, for example, it doesn't really make sense to force the user to implement evaluate. We will make get parameters configurable. So far, all client methods have this config dictionary, but get parameters doesn't so far. So it'll get it. We'll update the strategy interface with a couple of changes. And the virtual client engine is finally declared stable. And let me go into this because this is quite an exciting change. The virtual client engine allows you to scale experiments considerably on pretty average hardware. So we made a survey of what kind of scale different federated learning papers use to date. And we can really see the x-axis, by the way, is log scale. And we can really see a big cluster at around 100 clients and 100 to 200 concurrently in the same workload. And this is really just nowhere close to where production, especially cross-device cases, really are. So the research that we're performing and the actual scale are vastly different. And don't get me wrong, the authors of these papers have all done an amazing job. Simulating these systems is not trivial, it's very difficult. But from a framework perspective, we want to make it easier and we want to help them to push the boundaries. So with the virtual client engine, we've performed experiments with more than 15 million clients. And the more important part of the important part is we selected 1,000 of them concurrently in the same workload, and this was on pretty average hardware. So it was a single machine with a few GPUs in it, with the virtual client engine we were able to scale this up. So virtual client engine allows us to scale the experiments, and then with the edge client engine with gRPC connections. We can really move these workloads eventually to real devices and perform it eventually in the real world. Flower Baselines is another initiative where we are starting to collect existing work and allow researchers to build upon this existing work to implement and test novel ideas. There will be more details about this in the Flower ecosystem update, so make sure to not miss that. And summarized for different kinds of users, this means that as a researcher, you can scale your experiment, you can explore real-world properties by running it on real devices, you can build up on existing work using Flower Baselines. As a startup, you can just quickly explore and prototype new ideas and then quickly launch them to learn and validate these ideas, and you can build products that have a really built-in network effect. And also maybe important to you, you can attract the best talent. The Flower community has some amazing people, and many of them quite like to work with this framework. As a larger organization, whether that's an enterprise or some kind of nonprofit, you can deploy and operate these federated learning workloads at scale. You can run it in the cloud or on premises. You can collaborate with others without having to share the underlying training data. And you can leverage your existing investments in machine learning by just bringing your existing models and plugging them into Flower to federate them. So 1.0 is a stable foundation for future growth, and we will not stop there. Pre-release will be available in June, and the stable release is planned for July. But we also want to give an outlook on where Flower is going next, and a couple of the things that we've already started to work on, that we've started to prototype, and where we think a lot about. One of them, well, we're asking ourselves the question, what do we really need to achieve this vision of having a modular, agnostic infrastructure for these privacy-preserving kinds of workloads? And one of the things that we realized is that today, Flower feels more or less like a single tenancy system. This means you have just one model on the server side and one model on the client side. It's possible to build setups that have multiple models on the server side and multiple models on the client side, but it can be non-trivial to build. So one of the initiatives we're working on is multi-tenancy, to have workloads that are running independently on the server side on the same fleet of clients. Another one is async-FL. So we want to bring FedBuff and a lot of other algorithms to Flower. It's already possible to do async-FL, but again, it's non-trivial and you have to mess with the server class and it's not properly documented. And we want to provide a really nice way of building these async algorithms. Another one is modular secure aggregation. The modular part is quite important here. It wouldn't be too difficult to launch, for example, some version of plain secure aggregation in Flower. And we have working prototypes that we learned a lot from, so they were very valuable to build. But we hesitated to release this really because it's not modular. It would be just one implementation. And this is also a field that is evolving rather quickly. And we want to provide abstractions that allow you to either use some of the built-in secure aggregation protocols or to actually explore new secure aggregation protocols. So things like SegEgg Plus, Light SegEgg, Fast SegEgg, and then there's eventually going to be Next SegEgg, and we want to be forward compatible, similar to how we did it with strategies. Another thing that just has a working title, this name is not decided yet, is Flower plugins. So there are certain capabilities, especially integrations with third-party systems like TensorBoard or MLflow or weights and biases. Those things, we could build them into the core framework, but it's really, we really don't want to do this because it would be a huge maintenance effort, and it would be difficult also for users to bring in their own integrations. So we want to make a sort of standardized integration point. Let's call them plugins or callbacks, or we'll see about that. And then provide some built-in plugins for the most common things like TensorBoard, for example, but also enable users to write their own plugins. Last but not least, we want to have a fully programmable server. That's just zero code. The API is definitely going to change there. But right now, the federated learning loop that performs different rounds is pretty much baked into the server. Again, you could customize this by bringing your own server implementation, but really this is not a very accessible way of doing it, and it requires quite a bit of object-oriented fiddling with these classes and so on. So we want to make this way easier and provide a very nice way of programming this. This is closely related to the multi-tenancy effort. So once we have the multi-tenancy, we'll pretty much get this for free. But I think it will provide a lot of flexibility. We've actually wanted to do this for quite a while, and we had different working prototypes, but we were never happy, really happy, and we really couldn't guarantee forward compatibility, what we want to have for 1.0 with these approaches. But now we have a much better idea on how to do it. It will take a little bit of time, but I'm quite happy with the plan that we have so far. So, as I was saying, Flower has been growing massively over the last year, and while this growth has been amazing, we are also facing some challenges. Simply speaking, we need more hands and eyes, and especially brains, to review pull requests, review issues, get back to questions in GitHub, write documentation, that's a big one, build Flower integrations and things like that. And we are also thinking beyond the mere technical aspect, we're thinking about how to evolve the organizational aspect of Flower. So what kind of organization do we need? How do we want to organize ourselves to really bring together industry and academia and engineers and researchers and security specialists and contributors and supporters and other projects and everyone else who's interested in this? How do we bring them together in the best way to collaborate on this important initiative? Well, Flower started out basically, as Nick was saying earlier, as a collaboration between the University of Cambridge and adapt. And pretty quickly, it has grown beyond this collaboration. We gained a research community and an engineering community. And since then, more and more organizations joined this, more organizations from academia, more industry organizations, more companies. And it's now probably pretty obvious that we need some kind of central hub to organize all of these efforts around this. So this is something that is in a very early stage. We're calling this Project Flower Foundation, and really want to create this single hub for the whole community to come together, whether that's a university or an organization or an individual contributor. We want to provide some way of them of interacting and just collaborating. We don't have the details figured out yet, but we already wanted to share this idea and already be transparent about it and also collect ideas from the community. So if you have thoughts on how to do this, we are really in a super early stage when it comes to this. This could be something that stands on its own feet. It could be part of another organization. We basically haven't decided anything yet. But we want to have this early call to action for you to get in touch if you're interested in collaborating on this together with us. So that's it for the Flower platform update already. Flower already has quite interesting capabilities. We are now soon will be 1.0 stable. We have capabilities for both cross-silo and cross-device FL. We have the Edge client engine and the virtual client engine, which enable you to tackle very different scenarios. Community has grown massively. And I think we also have quite an exciting roadmap ahead of us. We'll soon have the Cambridge Flower course. We'll continue to invest in Flower to allow you to scale your experiments even further and more easily, try to support more devices. We have Flower plugins and async.fl and SecEg on the roadmap. Multi-tenancy will be a big one. And yeah, that's it for the Flower update.